So that'll be great. We'll have a lot of time for questions at the end. So I guess I'll start out first by introducing myself a little bit for those of you who don't know me. My name's Thomas Jackson. I'm a longtime contributor of Salt. Whoa, loud. I've been contributing for the last 5.5, almost 6 years now. I've been using Salt since 09, I believe was the first version I started using. That's pre-Reactor, pre-events, pre-state system. All that worked then was the remote execution sometimes. It's come a long way since. And I'm currently the principal infrastructure engineer at Wish, which is a mobile e-commerce company that you may or may not have heard of. We're the #1 shopping app on Android and iOS and have been for a while. So some of the, we run some pretty big infrastructure stuff and been just switching over. So when I joined Wish, we were doing all of our infrastructure automation through a variety of different tools, through some Fabric scripts, Chef stuff, a bunch of different things all over creation. And so one of the things, the main point of the first part of this talk is to talk about how you pick an automation platform. This is kind of a hard problem that people run into when they need to start automating some things. They don't know how to really pick what they want to do. So that's basically the first thing we're going to talk about is what is an automation platform, sort of how you pick one, how does Salt compare to the rest of them, fit with those requirements, and then we'll kind of go over some overview and best practices. Hopefully you guys can read this. Template's a little thin words. So quick aside, I usually throw lots and lots of memes in here, and they're usually really good quality, but meme generator's down. So if you work there, please go fix it. The rest of the internet would really appreciate it. But I got some low-res ones, Google Cache, saving the day. So first things first, what is an automation platform? All right, everyone, it's kind of an abstract term, I guess. What do you even mean by that? Usually when you talk about automation, the dictionary tells us that automation is the use of largely automatic equipment in a system, which I have no idea what that means. If someone has a better way of explaining that, let me know. Basically, automation is just making it so that we don't have to touch stuff because we are too busy or too lazy to do so. So what do we mean by an automation platform? So let's kind of spend a little bit of time talking about some use cases first that would maybe necessitate some sort of platform for automation. So the big one that everyone thinks of is config management, right? We config management all the things. This refers to, of course, managing all the system configurations. So this is something like which users are on the box, which packages are installed. Have we updated the various things like SSH or whatever, or Bash for whatever the latest vulnerabilities of things that have come out are. And so traditionally, this is what was, sysadmin work, right? You called up some guy, and he would do some magic on some terminal, and then magically your server was better or worse or something. And so the big question is, of course, why do we want to automate this, right? There's that guy that I call sometimes that can type a typo, and things work most of the time. The main reason we want to do this is that it's slow, right? Having to call some guy to do something is kind of slow because if I already know what I want to do, especially if it's a repeated thing that I want every couple days or every couple hours, that's too much. It's very error prone when people are doing it. So this is a common problem you'll see across the industry. It's not just sysadmins typing in stuff or DBAs typing in commands. People tend to typo things because these fingers, and keyboards, not the best mechanism. And then the third one, it gets kind of expensive. So when you go from your 1 server to maybe 10, maybe that guy can keep up, but once you go to thousands or tens of thousands of servers, I don't know about you guys, I'm even a pretty fast typist. I can't keep up with that many servers. So this is why we look into sort of automating these sorts of things. So for this sort of a configuration management workload, there's a couple things we want to right? We want controllable execution order, right? So as I'm managing the state of a system, right, there's certain things that depend on other things, right? If I'm going to have a service running as a user, you have to create the user first. It's pretty simple, right? Not groundbreaking, just throwing some stuff up here. Idempotency is really important. This is the ability to just run something over and over again and have it complete eventually. So this means that if my add user somehow fails in the middle, I don't have to come and then do magic to fix it so that it'll run the next time. I can just keep mashing the button until it works. And then constant and consistent enforcement is another big one. So as we're moving from our one guy touching the boxes all over creation, having a system that can maintain the state for us as opposed to just doing it the one time is immensely helpful for a variety of reasons. So the next big use case that people are talking a lot about is compliance. right? So you've got various security requirements for things, like I can't listen on more than these ports, they can't connect to certain things. And so this is another place where we have some different requirements. So we usually want to do some sort of spot checking, right? So I want to say, can this server talk to something? You know, can I connect over here? Do these credentials work? So you need some sort of remote execution because you need to run it from some place to check some other thing. We need some sort of continuous checking, right? And this may be from a centralized location. This might be from all the individual nodes, depending on what your requirements are for compliance. And you usually want to bundle all this data up somewhere so that you can run some reports and whatever, so that you can tell people that, yes, we're great, or no, we're terrible. So that way you can make that distinction. And then the last one I want to talk about is some like automated remediation systems. This is pretty common. People are starting to make these things now, which is pretty cool. So when the server dies, we'll go up. The more common one you'll see is stuff like auto-scheduling for things like Kubernetes or those sorts of things. I kind of bundle these all into the same thing. I've got something that's watching the system and making changes to the system. So for these, we need really reliable remote execution, right? If I need to go spin up or down containers or restart the service because it died or add more capacity, these things need to work. So I need it to be reliable. The code needs to interact with lots of different types of systems. As much as we want, as operations E-type people, to have one OS on one hardware spec, in places with perfect uptime of power and no disk failures, that never happens. We always end up with every single hardware vendor you can imagine, with every single OS on every version, with every patch level that's stuck there for some archaic reason. And it doesn't matter how young or old your company is, this always seems to happen. So we really need whatever system to support these. What is an automation platform then, really, is the question. So for this, there's many tasks that have a lot of these same requirements, right? So from that, we saw that we needed consistent interfaces, remote execution, and a bunch of these things that kind of fundamentally are the same across these. And if we were to build all these as separate products, we're going to spend a lot of time making a lot of the same features for a lot of different people, running into the same bugs and all sorts of problems. So remote execution, tracking of task completion, interaction with underlying systems, et cetera. Lots and lots of these same things. And this is where platforms become very important, because if we can make a platform, we can leverage it to build out our very specific use cases. And of course, all these vary from OS version to OS version, maybe with your driver versions, all sorts of nonsense. So how do you pick one, right? You kind of need one, it seems, especially as infrastructure is getting larger and more complex. We no longer can have the 5 guys sitting in some basement somewhere typing furiously to keep everything running. We really need to get some robots involved because we need to sleep at some point. So you need to choose, but you don't want to make a bad choice because then you're going to be stuck with a lot more work or maybe nothing working at all. So really what you need to do is come up with what your requirements are when you're trying to pick an automation platform. So some things that I think you should keep in mind, we'll cover here in a bit. So ease of use, testability, let me click through these. Ease of use, testability, productionability, that's not a real word, but it fits nicer, and extensibility are kind of the top levels we want to go over here. So first one, ease of use. So when we're looking to get some sort of automation platform, how many people know the automation platform? One of the most expensive things with teaching people how to use automation is teaching them how to use the automation platform. This I've done in some previous places where we built in-house stuff, and there's some documentation, but it's not great. That seems to always be the case, right? Documentation always falls down way below in the priority list, so it's never good enough. So how many people already know it? If they already know it, we don't have to do anything. This is especially important if you're trying to switch. So if you're already running in an environment that uses, let's say, Chef or Puppet or something, right? Or maybe some internal tool, they're used to a specific work interface, right? So we want to keep that in mind, right? What are they used to dealing with? What's the analogy they're working in, right? What's the learning curve for picking up this new thing, right? This one varies a lot from the different products, and Salt is not, free learning curve. The hardest part, I think, is learning all the names of things. Like first question people ask is, what the heck is a pillar? I'm like, well, it's a cutesy name for something. So all these sorts of problems, right? And then what does the user interaction look like, right? Are they going to be logging into a terminal and running some stuff? Is this completely automated, that stuff need to be running on a cron every now and then? Is this, do you have some sort of internal tool that needs to fire these jobs? These are the sorts of things that you need to understand what kind of scope you need. And so this includes all the audit roles that you've got. So if there's any system that needs to come in and do like some sort of PCI compliance audit or whatever it is, you need to be able to handle all those inputs. From the testing side, as we grow, we're going to end up with a lot of people that are touching stuff, which aren't the 3 guys in the basement typing away. And this is more common than you'd think. Someone will type something in, they'll commit it, they won't test it because they're too busy. They'll push it out and it'll break a bunch of stuff. And this is, to avoid this problem, we want to make sure that whatever platform we build is easily testable so that it's easy for them to do the right thing, right? So how can you test changes? And so the concept of code versus data. So some of these automation platforms out there are basically just like arbitrary code execution frameworks, which means that it's a bit more of a challenge to test certain things because you have to now test code complexity, not just data complexity. And then the last, second to last one, I guess, is productionability. So like how do you control what this is running on? How will you test new configurations? How will you know what's getting pushed when? How will you handle failures and interactions with other systems, right? Whatever automation system you're going to build is going to have to live in whatever environment that you have. And so it's going to need to interact with other systems that you have, as well as deal with the scale and problems that you have in production. And this may be something like I've got a really crazy network setup that's super segmented. I'm going to have tons of, in Salt's case, masters all over creation with weird syndication, whatever it is. Making sure you understand the environment that you're going to go into is really important. And then the last one here is extensibility, right? So once you've if you're going to go ahead and take the effort and time to build an automation platform, we want to make sure that we can use it for a bunch of stuff and wire in all sorts of other things and grow with it. And how can you integrate with other systems? So especially large companies or even some medium-sized companies usually end up building some sort of internal services for topology management, configuration management, secrets, like the ones that we've heard about some in talks today is like HashiCorp Vault for secrets, all these sorts of things. We don't want to necessarily build them all, but we need to be able to interact with all these. So the question then is, how does Salt stack up? Ha, ha, ha. Yes, pun intended, and here's another pun. Okay, see? Okay, there's like 2 people that are awake. Good. Okay, so how does Salt stack up for ease of use, right? States require a data structure. So if you guys have written states or messed with them at all, there's many, many ways of getting them through the YAML stuff, Jinja, whatever. But at the end of the day, it's just a big dictionary of stuff that's got a specific format. So it makes it pretty easy to do some validation on. There's also, as I mentioned, pluggable rendering. So you can do it in YAML and Jinja. There's even a PyDSL thing. You can even just straight input Python that goes and talks to some other service that puts the data together and shoots it right back. So this means it's really easy for you to use, and it's also really easy for you to modify, right, as you're moving on. So if you have some specific use case that you want to abstract away nicer than what the states give you, you can make your own DSL or do whatever other mechanism you want. And there's lots and lots and lots of examples on how to use Salt states specifically online. And they're not always 100% complete for what you want, but usually there's a good starting point to go from. And there's a very active community, as some of you guys are here. So it's kind of too easy, really. Once you get all the formulas going out, it's mostly copy-paste, and the community is super helpful at working through some of the problems. So we'll kick on to the next one, right? So for testing, since states are data, testing is actually a lot easier than it is in certain other systems where everything's code. If everything's code, you now have to worry about all the code problems, like will it complete, will it crash, will it corrupt data, all these sorts of concerns. Whereas if it's just data, I need to verify that the user inputted data adheres to the constraints of the system. So for example, if you, the user, are saying, I want this package installed at this version, all I need to do is make sure you gave me a package name that exists and a version that's real. And I don't have to do any of the other stuff about, do I know which system you're going to run it on, Debian, Red Hat, or Solaris, or whatever, and know the intricacies of the package management system. I can just deal with the top-level problem. And so this means that you can separate all your code testing from your data testing. So this means if you need to go make custom state modules or custom execution modules, you can test them separately from the usage of them. Also, for all of us lazy people locally testing, you can just run test equals true on stuff, and it'll tell you what it's going to do. And then there was some announcements earlier about this kitchen salt stuff, which is pretty cool. A nice wrap around the chef kitchen stuff, which will be really nice for testing a lot of the code stuff under the hood for you. So the next one is production size stuff. So in my experience, one of the big problems we run into with some of the other systems is how you define what should be running where. Like Chef, for example, has cookbooks that you'll upload, and then there's this whole system internally about versioning those and making sure they get published correctly and whatnot. One of the problems I've run into is that testing them becomes pretty difficult because there's no concept of environments. There's not really a really well baked in testing methodology. So with Salt, this is actually very easy to do. I always end up using git pillar and git fs. And what this means is that you can then just map all of your states to branches, and then you can nicely test things. So this means that if I want to go test my new version of some state on some box, and it's like a huge crazy change, I can just go make some custom little branch, apply it to the one host, see how it goes as I'm iterating through, and then eventually go through a merge request against whichever branch that's supposed to be in, which then gives you a nice integration point for CI right on that pull request. And I actually have an example up on my GitHub page if you want to look at how to do this. It's pretty simple. There's a couple of config options to shove. But this way you can shove the file roots, pillar roots, all that stuff into the same repo and then have it split based off branches. It's also very easy to audit. So unlike some automation platforms, Salt actually keeps track of everything that it's run, not only on the master job cache, but you can use returners as well to keep track of all the events that have happened. So it makes it very easy to tell who ran what, where, and when. So you have the job cache, and you can also use events and the Reactor to then put those events somewhere else. Either do something with them, like React in the system, or just post them off to some other system. So extensibility. Salt, as you probably figured out by now, is basically all plugins. That's all it is. It's just a big plugin thing, which is, I think, why most people have a hard time describing what it is, because it really is just a platform of plugins that does some stuff. So this includes the state system, right? The state system is what most people end up coming to Salt for before they find out all the rest of it. And it in itself is just a plugin that didn't exist originally. So this means that if you have any other use cases or things that you need to build on top, you can build them in the plugins or with the framework. And then it also, even within the plugins, most of them are pretty extensible. So for the states, for example, there's all these includes and partial includes and dependency chaining across states, which means that states are actually quite reusable as well. So although my team may have a specific state for managing users, some other team may have one that's a slight variation, but we may be able to reuse a lot of the same states. The Python renderers, in my opinion, is one of the biggest advantages of the Salt ecosystem for wiring in your internal systems into Salt. So as I mentioned before, you may have your own topology service, your own configuration service, whatever the case may be, but you can wire them right into Salt. So as far as Salt's concerned, it's just regular pillar data, it's just regular states data, and you don't have to worry about trying to re-implement all that or translate all over creation. You can just write the little code in here that knows how to talk to your internal service and do whatever dance of magic you need to do to get the data. And then that means that the users can stay in the Salt paradigm, which is nice from the documentation, help from the community perspective. And then you can do all sorts of event-driven reactions from the Reactor. And there's that experimental thorium state-based reaction stuff, which you can also play around with if you're interested in. And then there's other tools. If you have other tools that need a call into Salt to run jobs or whatnot, there's also the Salt API, so you can run everything over HTTP. So this includes stuff as simple as I pushed a new version on GitHub and I want to make sure I trigger the Salt master to update. You can use that. You can also have your external auditing tools or whatnot fire their commands directly to the API to have Salt run it across the infrastructure. So at this point, right, we kind of covered more or less how Salt compares to as a platform. So I want to kind of go over some of the components and some best practices when you're rolling out Salt in your infrastructure. So there are lots and lots of layers, so there's no way I'm going to be able to cover all of them, and so if you have questions about some specific thing after or whatnot, we'll probably have time. There's not that many of us. So I'll go over some of the ones that I think you'll probably run into and everyone's probably using, so hopefully it's not too boring. If it is, make sure you snore so they know that you've fallen asleep, and I'll just move on. Okay, so the first one, grains. What is it, right? This is hopefully helping people that are trying to get over the cutesy names of things. Grains are basically just metadata about a given node. That's all it is. So what are they used for? They're primarily used for letting upper layers of the plugin system know things about this host. So an easy to explain use case is like the package module, for example, right? There's multiple implementations of the package module for Debian and Red Hat and Solaris and all the different systems, but something has to tell it which system it's on. So this is what we use the grains for. So you can extend grains. You can make custom grains and do whatever you'd like in there. But some things to keep in mind with that, the grains at the core are really intended to be more or less static metadata about the host. So you wouldn't want to put things in here about maybe like current load or current CPU utilization, because those won't change frequently enough. The grains only get refreshed pretty infrequently. But this is a great place for putting stuff about the physical hardware, maybe rack location, RU in the location within the rack, on those sorts of information. You can also put some stuff, depending on the specifics of your environment, about what the current state of your system is. So if you wanted to store what is currently running on this box, you could do something like that, what is currently provisioned to this box. So the next layer up, if you want to think about it as a layered thing, right, is the execution modules, right, which are called the modules, which is confusing, but they're execution modules. So we'll just stick with that. So what is it? It's basically just a module to handle the interaction with an underlying system. So like in the package module, package state specific, there's modules that'll deal with the various different OS versions. That's all these do. They just give you a nice function and args interface to some subsystem. So they're used, yeah, I already said that. So best practices for these. When you are making these, make sure you have clear documentation about what things do. This is, in my experience with people writing them internally, this is one of the biggest problems, that people will write some function that does something, that's got something magic somewhere, and then no one has any idea what it does or what the limitations are. You want to make sure that you have consistent argument return types when you're making these functions. Since Python doesn't enforce specific return types, you can make a function which will return a string or a Boolean or a number or a dictionary or a list or a generator. I don't recommend doing that because it'll be very confusing for people that are using it to know what type they're going to get back. So try and be consistent with your return types. Make sure to use the virtual function. This is how you specify to load the module or not based off underlying system behavior, right? Whether this is a Red Hat system or a Debian system, those sorts of things. And then make sure that the functions are pretty small in scope. So we really kind of want to stick with like a Unix philosophy here. It's better to have a larger number of functions that do small numbers of things because we'll be able to use them better down the road. It's a Unix philosophy. So the next layer on top of that you end up using is the state modules. So the state modules are just modules with a very specific markup for arguments as well as return types to enforce that a certain thing is in a specific state, right? So that's all they're used for. So under the hood, the state module will actually be calling all the different execution modules, but they actually don't have any idea about what your underlying system is. So for example, the package state will just say, I want Apache and I want it at this version, but it has no idea what OS you're running on or any of that stuff. That's up to the module to do, right? So, So the big things that are different between it and the regular execution modules is there's a very fixed return format. You'll actually get errors if you try and return something that doesn't fit. And this actually defines a state that needs to be in, not a specific function to do. So the reason why is because we need to use the returns from this to run in the state compiler to determine requisites and those sorts of things. So that's why the hard constraints. So best practices with this. Once again, clear docs, not too magic, and then this Unix philosophy thing. A common pitfall I've seen people fall into is they've got some custom internal deployment mechanism that they're doing, and they'll make one big state function that says, make it so, or something, which does all sorts of stuff, and it's very hard to reuse because as you're going to change that process over time, you're going to have to copy paste that entire huge block of stuff and then change something in it, and you're going to end up with lots of code dupe. So it'd be better if you can kind of break it into various states that need to be done. All right, so now that we've kind of understand the grains, execution modules, and state modules, let's kind of talk a little bit more about the state system. So the state system is basically a combination of the top SLS, which is what defines what you're targeting states to determine which of the actual SLS files to run. And so these SLS files are used to define the whole system state as opposed to a specific function, right? Nothing too fancy there. So when you're writing out these various SLSs that are tied together in the top file, be explicit about your dependencies when you're writing them. So if you have this directory that needs to be created and depends on this user, throw in that dependency to user because people move things around in SLS files. And if you don't call the dependency, you're going to be relying on the specific order in the file. It'll also make it a little bit clearer from someone coming around later trying to read to understand what the actual dependency chaining is. Try and keep your SLSs as generic as possible. This is kind of this balancing act, obviously, where you're going to try and make it do what you need it to do, but keep it generic enough that you could potentially use it for something slightly different in the future. So the best way usually to do this is to try and keep as much of the specific hard-coded data as possible in the pillar. So if you need to know the version number for something or where to put the config directory, those sorts of things fall really well into pillars, so that way you can reuse the same state blocks for different hosts with different pillar data. So since I talked about the pillar data, we got to talk about it. So what is it? It's just a dictionary of data that's specifically for a minion that's built by the master. It's a cutesy name, but that's all it is. So the big difference, besides it being just a dictionary of stuff, because grains are also just a dictionary of stuff, is that the pillars are rendered master side. And in addition, the pillars are actually encrypted specifically to the target that they're intended for. So unlike most of the rest of the communications in Salt, which use a shared AES key across the cluster, this is actually encrypted specifically for the target, meaning that if some other minion were to get the packets of the pillar, they can't decrypt it. They don't have the key. So if you have secrets and whatnot, you can put them into the pillar, and they'll be seen on the master and the target, and that's it. So it's generally used for topology information, like what should be where, config options, those sorts of things, as well as secrets. So best practices here, make sure that your targeting is as simple as you can get it. Since the pillars are rendered master side, any complex targeting that you're doing is all going to be executed on the master. So you're going to want to try and keep it simple so that it'll scale well. You're going to want to try and define schema for the pillar structures as you're moving along. So as you're building, let's say one for console, let's say, you're going to want to try and define some schema so as people are coming later to make changes to it, they'll be able to fit it in nicely. I'll have an actual real live example we'll go over in just a minute that shows that. And then make sure you put your secrets for services in here if you're going to be putting them in the Salt at all. The pillars are the really great place to put that. There's also options if you want to encrypt it. So if you want to check it into source control, for example, you could use something like the GPG renderer so that it's encrypted in source control but decrypted on the master. So the last big kind of component that we want to talk about, because most people are using Salt not only for all the state stuff, but as managed Salt using remote execution. So let's talk a little bit about the Daemons. So for the Daemons, there's basically just a master and a minion, and there's a special variant of master, which is called the Syndic. So what are these used for? They're just used for the remote execution stuff. And this is where we can actually pull all sorts of files and whatnot through the file server in the master. So best practices here. I highly recommend using the TCP transport, not the 0MQ transport. The 0MQ transport is still the default, although it'll be switching probably next year to the TCP one as the default. 0MQ has some weird problems with scale. If you're interested in, we can chat afterwards, or you can, I talked about it, I believe, back in 2015. There's a lot of weird off-storm problems that you can get into. Plus, 0MQ sometimes loses messages. So highly recommend running the TCP transport. Scales a lot better, doesn't have as many weird failure modes. So on the master side, like I mentioned before, I highly recommend running some sort of GitFS system. That way, if you want to start stamping out more masters, they more or less take care of themselves. And on the minion side, you want to make sure that you configure backoffs. So if the master is overloaded, you can configure what the exponential backoff will look like. And similarly, if you want to have any sort of scheduled tasks to run, configure those on the minion if you can. You can also configure them through the pillar, but if you have certain audit tasks, for example, you don't want to have to rely on the master being available for the audit to run. Okay, and then the last one here is the Reactor. So this is just an event-driven system that takes events that have happened and does something with them. There's no state maintained, it just reacts in a single event. So you usually use this to run some specific SLS when an event happens. Some common use cases that I run into are like cleaning up keys that are unused or dealing with key conflicts. You can also do some stuff as when systems boot to go fire high state runs and those sorts of things. So with this, you want to keep in mind that the event system is best effort. So if you only are going to fire the event exactly once and you need to catch it, this may not be the best place for it, but that's not usually the case for most infrastructure things. So just keep that in mind while using it. And avoid computationally expensive tasks. Since these reactors are also run on the master, you don't have as many of them as you have minions. So more common is to fire an event off to some other system for them to go do some more expensive work. So I want to go over a little bit more of a practical example, since you guys are probably all bored to tears and falling asleep at this point. So let's talk about writing some states up for a Mongo box, because people still use that. So in this example, we'll basically set up Mongo. Mongo requires some special formatting, so we use XFS. We're going to have to set up some directories with some permissions, and because we're awesome, we're going to be using Console for service discovery and Prometheus for monitoring, right? So here is some pillar data, which you may or may not be able to read. Hopefully you can, which looks very similar to, actually, if you look, there's a Mongo salt formula up on GitHub. So this looks remarkably similar. You'll notice here we have some configuration options that specify the user and the group for Mongo. I've left out a bunch of other ones because the slide's not that big. And then you'll notice there's some other information here about the server, telling you whether the server should be enabled, who the master is for the shard, and the members of them that somehow got crazily formatted. Thanks, Google. And then what the name of the replica set is, right? So this is just boring configuration stuff. But you notice at the top, we also included the Prometheus and Console one. So let's look at those real quick, and then we'll come back. So in the Prometheus one, something similar. Right? There's a configuration layer, which specifies where Prometheus is going to be, what user, what group it is, and then a map here of what the exporters are. Right? So this is, if you guys aren't familiar with Prometheus, exporters are basically just a service that runs on the box, which exposes symmetrics on a port. That's all it is. So this is just a map of, if you wanted this name of it, here's the source for it, and then some other various config options if they exist. So, and then console, which probably more people are using, similar thing, configs, and then I leave this empty map here for local services, which we'll use here in just a second. So, at the rest of the MongoDB SLS file in the pillar, I have basically this. So you'll see here we got Prometheus and the local exporters, and then I specified this MongoDB exporter and then nothing. And in console, I've specified some local services and some data. So what this ends up doing, since the pillars will be merged as they're imported, these actually get merged into the Prometheus and console pillar themselves, which means that I don't have to, when I want to go add a Prometheus exporter or a console service, I don't have to modify both my pillar file as well as someone else's pillar file, as long as I adhere to whatever their schema is, which in this case is basically just merging the local exporters and local services maps. So what this means is you can just include them, they'll get merged together, and that way you don't have to worry so much about if someone's trying to run a specific state versus all the states, clobbering all the console configs or clobbering all the Prometheus configs. So on the state side of things, we do something fairly similar. This is also, once again, simplified, but basically something to just say, if the pillar exists for Mongo or console or Prometheus, I want to run those states, right? So we're basically using the pillar system as the topology service here. And so this way you can enable or disable services just based off of the metadata being there in the pillars. So some other things that I wanted to cover real quick. Common problem that people run into, or question that people have, is how do I manage masters of Salt? Right, I can manage all my thousands and thousands and thousands of servers, but I've got these small number of masters, and how in the world do I manage them? I highly recommend using Salt SSH. Salt SSH has some awesome stuff. It uses all the same SLS files that you already did, so you already learned how to write them, you already know what you're doing with those, you can use the same ones. You can avoid the circular dependency of trying to use Salt to manage Salt on the master, which needs a master, because that becomes a mess real quick. Now, it doesn't mean that you can't use it, right? So for Bootstrap, right, we can never make the circular dependency work. But later, we could actually reuse the same states on the master to have it maintain itself, and then when broken, some person can come in and just run it again through Salt SSH to fix the problem. And when you're deploying masters, I highly recommend planning for failure. Right? A lot of people will stand up a master somewhere, and there'll be just the one, and then it'll die at some point, and it'll be very important that it comes back, but no one has figured out what to do with it yet. So make sure you plan for that, whether that is running more than one master, having a DR1 ready to go. Make sure you plan ahead. And if you want, I actually went over the various different multi-master options back in SaltConf 2015. If you want to, these slides will go up, so you'll be able to click through the link. So some just general best practices stuff. This applies to Salt as well as in software life. Some best practices. You want to reuse code as much as possible. And in Salt, we can kind of extend that further and say we want to reuse states or pillar data as much as possible, mostly because we're lazy. You shouldn't have to write everything all the time, but that also means that you won't have to test everything all the time. You can just leverage stuff that already exists. You want to also keep things general where possible. A common pitfall people fall into is to make something super specific. So we'll have some plugin that does some magic, huge function of stuff. We don't like that. Also, try and remember when you're working in the system what the plugin layers are responsible for. Although you can reach out and do other things, try and stick in the model. It'll be a lot easier, not only for yourself, but for other people that are going to be using it later. Then as you're working with this stuff, also try and think about the scale that you're working at, right? So there's many things that work out of the box in Salt. For example, like you might be able to just use the pillar data to define your topology. Grains might give you all the information that you have, but you can extend the functionality of Salt either by writing your own modules, by creating your own custom grains, or wiring in your own external services, like your own CMDB or topology service or whatnot, so that you can still use Salt, but use some other service to maintain a lot of the complex change management process. And while you're doing this, the regular service-to-service communication rules apply. Make sure that you have clean interfaces and translate where necessary. So pull topology data in as pillar data, instead of trying to wire it in as grains or something else. And then generate the states from some configuration management or something. So lots of lots of options. But really, at the end of the day, the big thing to remember is that Salt is a platform. So it started as you start to use it usually as a remote execution, and that's what Salt started as, was remote execution. But all the rest of it's just been built on top of it. And so you can do the same. So everything else has just been added afterwards. So when you have Salt in your infrastructure, when you're going to go build some new infrastructure piece, take a look at leveraging Salt. It'll end up potentially saving you a lot of time, and that's where you really start to get a lot of the big benefits, is because you can continue to leverage the work that you've already done and you're already maintaining and you're already supporting. Right. So that's actually my presentation. Are there any questions? I guess not. Okay. Well, good. Everyone gets a break.